Hey everyone, let's take a look at number 28 in section 5.1. I think this is the last one in this section. We're going to use using the R sub n, so the right approximations, express the area under the graph of this function, 3 times the sine of x, over this interval from 0 to pi over 2 as a limit. Okay, so we've been evaluating these, calculating R sub n, and then taking the limit as n goes to infinity. We're just going to set that up. We're actually not going to do that calculation. Look at this function, so we're not going to be able to do that, but we can set it up. So what's that look like? It's pretty straightforward. Remember, the area is the limit as n goes to infinity of R sub n. And R sub n, right, is just the right-hand sum, the f of ci times the delta x, so the height times the width of each rectangle added up from I equal 1 to n. By the way, they use capital N here. I'm going to use lowercase n. I'll put it back in terms of capital N. Same thing. I just prefer lowercase n as opposed to capital N. Then what's our delta x? What's the width of each of these n subintervals? Well, we're just going from 0 to pi over 2, so the length of the interval is pi over 2. Divide that by n. Pi over 2 divided by n is pi divided by 2n. So there's our delta x. For right-hand endpoints, remember, they're a plus I times delta x. So the value of a is just 0. And of course, I times delta x gives us that. So we get pi I over 2n. So now I can plug in, right? What is f of ci? Ci is this quantity, so I'm looking at f of pi I over 2n, and then times the delta x, which is this. Okay, so this is it. We just want to clean it up. Of course, what is our function f? Well, our function f is 3 times sine of x, right? That's the actual function that we're looking at here. So I'm going to replace the x in this function with the pi I over 2n to do this evaluation. And I get 3 sine, place x with pi I over 2n times still this delta x. So here it is. To clean it up a little bit, this is, remember, be careful. This is, I put a little dot here to emphasize we're multiplying, but this is not inside. So it's not sine of all of this. It's just the sine of what's in here. And then this whole thing is times this. So I can bring this up. This is like a numerical coefficient, pi over 2n. N, of course, is some fixed number before we take the limit. So this is just like a constant. I'm going to bring it up in front times this 3. So 3 times pi over 2n gives me 3 pi over 2n. And so here it is. This is the answer. This is the area under the curve, 3 sine of x over the interval from 0 to pi over 2, expressed as a limit. Now, going back to their notation, instead of little n, they use capital N. They also, instead of using the index I, like I used to use, they use j. Okay, so j, just replacing I with j. It's the same thing. So these two expressions are identical. We just are changing the variables a little bit. This is the actual correct response. I think this one is multiple choice, so that should be one of the multiple choice items. Okay, and again, your problem might be slightly different than this, but I think it's basically the same. So that's it. That's all I wanted to do is set this up. We can't actually evaluate this using the techniques in the section, but that's the way we would compute that. Okay, hope this is helpful. If you got other questions, please let me know.